Good afternoon to everybody. My name is Humberto Casas. I'm 21 years old and I'm a Peruvian student of the Department of Electronic Engineer of the book. Well, first, excuse my English. It's not my first language for that reason. If something is not clear, please let me know. And I repeat. Well, I was part of the Peru 126 and Team Peru, and we have worked in that presentation, which is the main observation of our project of the MDRS or future projects too. Well, together with my teammates, we have worked in that presentation to give recommendations to improve the simulation of what? Of the MDRS. Well, this place gives us many good simulation of what could be lived in Mars work and development projects too. But there are many things that have to change to have a better simulation. It's for that reason that we are working in that presentation to give the recommendation necessary to improve that. Well, since the Peru 126 14 Peru, I was part of them. Alex Diaz was the commander. I was the official executive, and Andrea Lazarte, the HSO, A.D. Onchi, the crew engineer and journalist, Monica Varga, the greenhouse engineer, and Saul Trujillo, the EVA engineer. Well, there is a reference if you want more information. And now, where we come from, most of us were students of the book in that university. Exception of Andrea Lazarte, who is from the Agraria. And there is some of the companies where which we have worked or still working now. Well, I start talking about the project there in the MDRS. First, the person. It was part of the speech shown yesterday by my teammate A.G. Onchi. And there is about waypoints which have atmospheric measurements of temperature, humidity, and atmospheric pressure too, and can locate by algorithms the astronaut position. Well, what was the main observation of that project? The problem that we had was the communication. First, we decided to work with the radio frequency, but it was too noisy. We used many algorithms to reduce it. However, we didn't get the expected result. For that reason, we decided to use the Bluetooth. However, the range of the Bluetooth is not too long. For that reason, we are now working in our next step, version 2.0. Other project was the average walking speed. Was my favorite project. It was to walk from the hub to a point of the distance of 1.75 miles. First we have to go and after come back. For that project we choose the winter and colder day. And we did with the in addition with the weight of the spacesuit and the uncomfortable of that, we get a good result. We determine the average walking speed is of the 2.57 km per hour or 1.6 miles per hour. However, we didn't do anything with the gravity. For that reason, we could have a closer result. Other project is that the EVA Emergency Transportation Development Test. This part of the speech will be shown in the next presentation by my teammate Andrea Lazarte. Well, it is about 7 different designs, which were tested in 3 different terrains. First in a soft, after in the semi-hard, finally in a hard terrain. Well, the designs are this. First in an ATV, later with a right, and later with only one wheel, with 2 wheels in parallel, with 2 wheels in series, with little 4 wheels in a hill, and a little 4 wheels next to the ATV. The advantage and disadvantage of each model will be shown in the next presentation. Now we'll talk about the observation of the station, MDRS, and when I mean not only the hub, but also the green hub, the observatory, and the Antarctica pile, which is very important too. For people that who don't know what is the Antarctica pile, it's a place where you can use many things which were used before for create new projects. First, the spacing. The spacing is very important for the simulation. Actually, we consider that something has to change. For example, the clothes. The clothes are very close to the body and it's a little uncomfortable and don't give a good physical appearance. Other thing is the helmet. The helmet costs too much and is very fragile. And the backpack is not too close to the body. For that reason, it's a little uncomfortable when you are in an EVA. Other thing is the airlock. The airlock is very simple. And you only have to enter inside that and wait for 5 minutes, and you don't feel anything. For that reason, we consider that put something, for example, a fan, to feel something that is going to happen to, for example, or maybe a vibration, well, not noise. Because only to be inside, to wait, is not little simulated. Other thing is the space food. We know that the simulation is more important than the comfort. For that reason, we consider that we have to only eat the same food that astronauts would eat in the space. But in the MDRS, we are not doing that, so we have to change that. First thing is the hub appliance. There are many hub appliances in the hub, and the lack of space is something to worry about. For that reason, we consider that we have to develop a project with implement a machine, a multifunctional machine, which can fry, heat, cook, and anything else. Because the lack of space is something very important in the MDRS, like as well as in the space. Other thing is the green hub. Green hub maybe is one of the most important projects, not only here, but also in the space. Because astronauts have to cultivate the food there. But actually, we didn't use it too much. Actually, we didn't use it. And maybe other crews neither do it. For that reason, we have to work in that and the development of that to improve the function of that. We made some modifications. For example, here we can see that before it didn't have a fan. It was for the summer period because the air inside was too hot. For that reason, we put a fan in the bottom of the green hub, and together with a extractor in the top of the green hub, we got to have a fresh air inside. And got to have the green hub open for the summer period. However, we didn't do anything for the winter period, and we consider that it has to be automatic. And for the reason, for the summer period, for winter period, do anything because it has to be allowed to take decisions. First thing is the precipitate way. There are two precipitate ways. First, from the hub to the green hub, and the other from the hub to the Antarctica pile. And the first, from the hub to the green hub, it has a structure. However, it doesn't have a cover which could be a plastic maybe, and give a more physical appearance, more special. But from the hub to the Antarctica pile, there are only some rocks, little rocks, to limit the weight. And it has to be an structure like the other, and maybe covered too. Now I'll talk about the hub outside. There are three things: the bathrooms, the ATVs, and the hub car. And talking about the hub car is okay because all is important: the comfort, the simulation, and everything. But the most important is the security. For that reason, the car has to be there always. no problem with that. But with the other, yes. With the bad ones, it gives a bad impression about the simulation. Because if you are in an ABA, for example, and you look at the balloons and break the simulation. For that reason, we consider to make a structure like the observatory to put the bathroom inside that. To situate them, disguise them, and to get to not to see the bathroom. And talking about the ATVs, not only look very grown, but also are very grown. For that reason, we have to change to the ATV used by electrical impulse, and maybe use some accessories which give a physical appearance like a special trait. Well, now we are working in many projects. Some of them is that, for example, the version 2.0. And the main difference, well, we're working with the radio frequency one more time, but with no algorithm and with better antennas. However, we changed something. For example, the main difference is that they now are able to be located by themselves. I mean, without the human help, because they will be jumper robots. Other project that we are working now is the new spacesuit for EVAs. For example, we can see here the Audas X. The Audas X is a project we are developing now in Australia by our Australian team. And well, the color could be anything, or for example, orange like the ACA's spacesuit, or maybe the silver like the Mercury in the past. Well, it was my presentation. If you have questions, I'll answer. And if you have some recommendation for the paper we will show and present in October, and this is my email. Okay, thank you. Thank you so much.
Can you go back to this picture of the spacesuit?
The first or the second?
This is the last one.
Yeah.
So what's that material there on the left?
This material is the Oretex. Oretex is very used for long period activities because it protects the cold and permit to evaporate the solar of the body.
Okay.
Oretex.
Is it expensive?
Not too much. Because it's very used for people who are working in the mountains or close to the sea.
So do you hope to build that spacesuit and take it out there and test it?
Yes, sorry?
You hope to build that spacesuit and to go test it at MDRS?
Yeah, with that material.
How many people back in Peru are involved in practice?
Now in the Mars Society Peru, we are 5 directors, but working in this project, we are more or less 20 people, between mechatronic engineer, ambientalist engineer, and psychologist too, and industry designer.
How are you dealing with the heat rejection on it?
Sorry?
How are you dealing with heat rejection? Overheating in the suit?
Sorry, I didn't understand very well.
High temperatures?
Temperature?
Yes.
The range.
Yes.
Actually, we don't have that information now, but could you let me your email and I will give you the information?
Certainly.
Thank you. Another question? Well, thank you so much for the attention.